So I think um, the thing that I want to talk about is this BFS and DFS. So um, this I think it's going to talk about depth. That means you go deep, but for this I think you go wide. You go that's why breadth. So um, coming to the problem statement, um, I think the move I really like that first and foremost like the color, it's vibrant. So um we go this, move on to the next, cancel out, and one thing to note is we sort of record. So we enter to the next. So and um once go to the next, I think we got chord one for it. I don't know, but we go the seconds, and then we call for the two, and then the next option we call for this and this, and since we go to the next step, we press the 3, go to the next step, the only available step is and this, and then 4, and each time we move next step, we kind of like cancel out the previous. So when we enter here, cancel, this, cancel, this, cancel, this, cancel, and for some reason it just started by here. I don't know, I don't know how, but start here. Every time we start next, that means it can be here, it can be here, so it can be here, it can be here, right? So we should register 4, we can cancel previous, cancel, and we go next. For some reason again, I don't know why this just disappeared, but you go here, which is the next steps, and you record 5, and you cancel the previous, and you go next, which is this and this, and I don't know why you don't record 6, maybe you do, just that it's not been drawn. I think that's pretty much it, and I guess if we were to find the beauty about this is that they don't actually check on every single conditions as compared to the previous, which is the DFS thing, because DFS do check up, down, left, right, but this one it just feels is very intuitive, that it just goes straight to the 0, and it just knows, and it goes the very ideal path. They go here, you go here, you go here, you go here, you go here. So it's very intuitive, it's very fast, it's very efficient. So that's why later it will say like big n times n, as opposed to the previous, which is sort of like a 4 and I don't know really why, how they derive this n and m, and I don't even know why what n stands for. I don't even know what m stands for. So it could be like the breadth and the width, the length and the width of the boxes of the matrix. So and one very cute thing is that it may go from here to here. but for some reason it go here, because I think if there's a conditional statement that checks something to do with checking with this, it will know the answer, so it will end the whole loop. um, and we don't really care about this because it doesn't meet the conditional statement of hitting this. It could be something that, since here is 1 2 3 4, maybe r equals 4, and n equals 4, m equals 4, given that here is considered to be n and here considered to be m. If n equals to 4, m equals to 4, this is the conditional statement. Or it could be the n minus m, which is 4 minus 4 equals to 0. That's why this will be the last one. It can be that form of conditional statement that actually helps us to cancel out this thing. So it one very concerning thing is like the previous is saying that it's very concerning that we don't really know what does DFS, BFS do, stand for. How does the story arc between the BFS and DFS actually link to the story? For my understanding, it's that BFS is so much faster, which makes a lot of sense. The big, we have first and foremost the big O of n times m, the efficient timeline. It doesn't go all the directions up, down, left, right, as opposed to the DFS. And DFS just acts the opposite. It's very inefficient. It go up, down, left, right. It do so much more on the big O, which makes a lot of sense because you go deep, 4 times n, and then it started talking about it can be possibly traveling all around of the scope, which therefore the 4 and m and yeah lor. Everything comes to an end.